Alright, let's get started with this lesson, 211 Algebraic Logic Part 2. And just to forewarn you, this video will be long because we are learning how to write two-column proofs in this video. And I want to make sure that I explain it well so you'll be able to do them without much suffering. Okay? And as I've said on many videos before, be sure to give me your course name, not course name, but course number. That shouldn't be name. I've read this 1,000 times and I just now realize that should be number, because I know you're in geometry. And your number will be like 203A or 204A. And then your section number could be 1 through 9. Alright, the objective in this lesson, is use two-column or paragraph format for proofs. Now, we won't do the paragraph. They do talk to you about it. Mainly what we do in this class is the two-column proof. So let's talk a little bit about the relationship between definitions, properties, and theorems, because you get to use all of these when you're writing a two-column proof. First, when you think about the roots of a tree, and I know this illustration is in your LMS, but when you think about the roots of a tree, that's kind of the foundation. That's what keeps the tree stable. All right? And that would be our undefined terms and definitions. Okay, those are things that we just know, and we've defined them pretty well. Okay? We haven't had to prove them or anything. Alright, and then here you've got the trunk of the tree. That's your postulates and properties. These are also items that we haven't had to prove, that we just know are true. And just think of the trunk and the strength that it gives the tree in holding up the branches and leaves and so forth. And then the rest of the tree, right here, which is your branches and leaves and things, that's going to be your theorems. That is what we have to prove. And when we're learning to do two-column proofs, we have theorems that when they first come up and said, hey, I wonder if vertical angles are always congruent, because I think they are. Well, then they went through and did a proof to see if vertical angles were always congruent. So that's what a theorem is, something we've got to prove. Okay, theorems and proofs. Now, this first part is just going to be kind of long, and you are going to have to bear with me, because this is all very important information you need to know in order to do a proof. It says a theorem is a mathematical statement that has been or is to be proven on the basis of established definitions and properties. Okay? Y'all have heard that a lot because we've said it a lot. Alright, now a direct proof is a major way of proving theorems in which the conclusion is drawn directly from previous conclusions, starting with the first statement. And of course, you're going to understand that a little bit better once we get into doing proofs. Then there's geometric proofs, can be written in two basic formats, the two-column proof or the paragraph proof. This is all stuff I've already read, I'm just adding to it. A paragraph proof is written in sentences and is more difficult than the two-column proof, which is easier to set up and understand. That might be why we're doing two-column proofs instead of paragraph. Alright, the statement that is to be proven is called a conjecture. And a conjecture is a statement you think is true, but still need to prove using deductive reasoning. Once a conjecture is proven, it's called a theorem. A two-column geometric proof uses deductive reasoning and consists of a list of statements, each with a formal reason. You'll have the given, definition, postulate, theorem, already proven, or property. These are the items that we're going to be using to develop our proof. And these justify how you know that the statement is true. The statements are always listed in a column on the left, and the reasons for which the statements can be made are listed in a column on the right. And like I said, this is all just verbiage that we need to know that you'll probably be tested on, but we're going to get to the illustration and start working examples in just a moment so you'll be able to understand it all. Okay, now we have guidelines for writing proofs. This could very well be a question as well on a quiz or test. You always draw the figure that illustrates what is to be proven. The figure may have already been drawn for you, or you may have to draw it yourself. Okay? I think most of the examples that you're going to work or you're going to see in our exercises will have a picture for you, but don't assume anything about the picture except for what you're given. After you've drawn the picture, you need to list the given statements and then list the conclusion to be proven. Now you have a beginning and an end to the proof. All right. Usually you don't have to list the given statements or list the conclusion. It's already done for you. Sometimes if they write it in a word problem situation, you may need to list them, but usually they tell you what the given and the conclusion is. You need to mark the figure according to what you can conclude about it from the information that is given. This is the step of the proof in which you actually find out how the proof is to be made and whether you are able to prove what is asked. Matter of fact, we're going to be able to prove all of ours. Okay? And I'm just continuing this on. It says, mark up all that you are able so that you can see for yourself what you must write in your proof to convince the reader that your conclusion is valid and accurate. What we are becoming is geometry lawyers. That's what it is. Okay? Next step is to write your steps carefully, even the simplest ones. Some of the first, oh my goodness. Okay, some of the first steps are often the given statements, but not always. And the last step is the conclusion that is to be proven. Now, and it says not always on your given being the first statement, but it's pretty rare that it's not the first statement. Okay, this is a very simple proof. Okay, I don't know if I can say very enough. It's a very simple one, but I wanted to help you understand how we're going to write geometry proofs. Okay, first they're going to give us what our rules are. Our rules say if Lydia wears purple, then Claudia wears purple. If Claudia wears purple, then Patty wears purple. And if Patty wears purple, then Joni wears purple. So here's our given. Okay, if Lydia wears purple, and here's what we prove. This information won't be given to you in the proof. This is just rules that I'm giving you for this very simple proof to help you learn how to prove something. Okay, I'll explain to you what our geometry rules are in just a moment. So our given, Lydia wears purple. We need to prove that Joni wears purple. Okay, first, let's look. I put this note here. This column in the middle, when I say we do 2-column proofs, notice this has 3 columns. This column in the middle is just like our training wheels. It's going to go away. But right now I'm putting it there to help you understand what we're doing. Okay, let's look at the first statement. Lydia wears purple. Well, why? And how do we know that? Well, we know it because it's given. It was given to us right here. It says, if Lydia wears purple. Okay, that's our given. The second statement says Claudia wears purple. Well, why can we be so bold to say that? Why can we say that? If we look up at our rules, it says if Lydia wears purple, then Claudia wears purple. Okay, so there's our reason. That's how we can say it because it's one of our rules up here. So if Lydia wears purple, then Claudia wears purple. Well, statement number 3 says Patty wears purple. Well, how do we know Patty wears purple? Let's go back to our rules. It says, hey, if Claudia wears purple, then Patty wears purple. Okay? So that's what you're going to put right here. That's your reason, is that second rule. If Claudia wears purple, then Patty wears purple. Our fourth statement says Joni wears purple. But why, oh, why can we say that? First off, that's what we're proving, is that Joni wears purple. Okay? But there's also a rule that tells us why Joni's wearing purple. It says if Patty wears purple, then Joni wears purple. So we put that in as our reason. And we're done. Okay, let me show you another little trick to this. Okay, we've been learning all about these conditional if-then statements. Well, we're fixing to put them to use because notice all of these rules are if-then statements, okay? Look here. In a two-column proof, each rule's if matches the previous statement, and each rule's then matches the current statement. So look here. For the first statement, Lydia wears purple. Okay? When I'm given my reason, okay, notice how if Lydia wears purple matches my previous statement, and Claudia wears purple matches my current statement. Alright? That ought to make this just a little bit easier for you to do. So watch this next one. The second statement says Claudia wears purple, so that's going to be my if in my third reason. If Claudia wears purple, see how they match? And Patty wears purple matches the third statement. And watch this, it works with the fourth one too. Joni wears purple, okay? Look how if Patty wears purple matches up with the third statement, and Joni wears purple matches up with the fourth statement. So remember that. Your if will always match your previous statement. Your then will always match your current statement. So let's look at some geometry. Well, not yet. Let me add this before I move on. Read the proof out loud a few times and let it sink in. And I've read it out loud a few times. Okay? Don't worry if you wouldn't have known how to create it. If you already knew this stuff, you wouldn't need to be in school. Just follow the logic and let it sink in. Okay? You are doing awesome. Just sitting here and listening to me talk. Alright. You remember I told you we had those rules. Here, let me go back. Okay, see, here are our rules. Okay? For this very simple proof. This was our rules. Well, in geometry, what we've learned so far since the beginning of school, here's our rules. Plus all the definitions that we've learned. Okay? I just didn't have the time or the space to write down all our definitions, but you can find all of the words that we've learned in your student guide. They've got them listed there. It says keywords, I think, in each study guide. If there are new terms, they talk to you about them and define them. Okay? Those are your definitions. So when we're doing geometric two-column proofs, we're going to be using all those definitions we've learned to date, plus all of these postulates and theorems, plus the properties we learned in our last lesson. These are all of our rules that we can use to help us prove theorems. So let's move on. I just want you, oh, by the way, I've got a PDF copy of this right here. I'm going to be having it in doc sharing. As soon as I get finished with this recording and get it posted, I'll be putting all that information in doc sharing. So that way you will have access to it, so you won't be having to flip back and forth through your reference guide, because I know from experience that gets tiring. Okay, here's our first geometric proof. Proving angles congruent. Alright, here's the given. They tell us angle 1 is congruent to angle 3. Look here. Angle 1 is congruent to angle 3. All right. They want us to prove that angle 2 is congruent to angle 3. So this is going to be our first statement, and this will be our last statement. Okay? And look what I've done down here. Oh, evidently 1 and 2 is our vertical angles as well. Hold on just a second. Let me make sure that's supposed to be there. Okay, I couldn't find the actual proof. I'd put these proofs together a long time ago and I couldn't find the actual proof, but I'm pretty sure it is supposed to be there. It just got cut off when I was typing it in. Anyway, so here's our first statement. Angle 1 is congruent to angle 3, and angle 1 and 2 are vertical angles. Well, how do we know that? Okay, remember, your first statement is almost always your given. That's how we know that. All right, now think about this. Remember my reason that I'm going to put right here before I go on? It's going to be, the if is going to be one of these. It's either going to be angle 1 is congruent to angle 3, or angle 1 and angle 2 are vertical angles. Oh, and it just dawned on me. It's not part of the given up here. We see it right here. That's how we know it's given. That's how we know they're vertical angles. Okay, so remember, your if part right here for your second reason is going to be one of these. It's either going to say angle 1 is congruent to angle 3, or it's going to say angle 1 and 2 are vertical angles. Alright, let's look at the second step. It says angle 1 is congruent to angle 2. Well, what rule guarantees that? Well, you go back and you look at those postulates and theorems, and if you notice, I think it's Theorem 2.3, it says that vertical angles are always congruent. So it's the vertical angles theorem. And as soon as I go through this and get finished showing you all this, I will show you the if-then statements that all match up. Okay, so now my third statement says, therefore angle 2 is going to be congruent to angle 3. Well, how do we know that? It's going to be the transitive property that we learned in actually reviewed in our last lesson. Alright, so let's just stop for a minute. You're saying, well, Ms. Poore, you're just putting all this in here. How do we know all this? Let's look at the if-then statements because it'll help make it really clear. Look here. This was our given. Alright. And this was the second statement that we made. Well, we know angle 1 is congruent to angle 2. Well, how did we know that? Because of vertical angles. But let's look at the if-then statement. It says if two angles are vertical, well, notice how I highlighted both of them with yellow. If angle 1 and angle, up here I said angle 1 and angle 2 are vertical angles. Right here I just reword a little bit, but it still means the same thing. Two angles are vertical. Then the angles are congruent. So that matches up with my current statement of angle 1 is congruent to angle 2. Okay, with my third statement, I said, whoa, well then that makes perfect sense. Then angle 2 is going to be congruent to angle 3. And that's by the transitive property. But let's see it written out in the if-then statement. Because this, when you see it written out like this is going to help you figure out what your rule is. Okay? So this says, this yellow right here matches up with this yellow. I'm trying to figure out why I made that yellow. I don't like that being yellow. But notice this right here. It says, and angle 1 is congruent to angle 2. These should be flipped. No, it shouldn't. I'm sorry. I have no idea. This probably shouldn't be yellow at all. So angle 1 is congruent to angle 2. That matches up with my previous statement, correct? Then angle 2 is congruent to angle 3, which matches up here. We had to have this in here because it's part of our given. Ah, that's why it's yellow, because it's part of my given. It's part of the given up here. That's why it's yellow. So I probably should have just left it white. But it needs to be there. Okay, so you can see the transitive property. All right, let's look at some examples. All right, here's our given. Measure of angle 2 is equal to the measure of angle 3. The measure of angle XYW equals 90 degrees. And the measure of ZYW equals 90 degrees. Remember how I said you need to mark up your figure, okay? I put this red line going through here showing that angle 2 and angle 3 have equal measures. And I put this black square right here to indicate that angle XYW is 90 degrees. Well, if I put a square here saying this angle is 90 degrees, this is automatically 90 degrees over here. Okay, so I did my marking up in my figure. I know this is my last statement, all right, and I know that this can be my first statement. So let's look at this. Okay, I put the measure of angle 2 equals measure of angle 3, and the measure of XYW equals 90, and ZYW equals 90. How do I know that? Because it's given. All right, now let's look at our second statement. This is where you're going to be challenged. What is going to be my second statement? That's what you're going to say. I don't even know where to start because I've been there. Okay, I was a geometry student once myself. So let's look and see where we went. Ooh, that's a good place. We know that the measure of angle XYW equals the measure of angle ZYW. Because doesn't 90 degrees equal 90 degrees? Yeah. Okay, remember, how do we know this? Other than we know 90 equals 90. Well, remember, with my if statement, I use this. Okay, and for my then statement, I use this. By writing out this statement, it'll help me determine which property, theorem, or postulate I need to fill in with. I put, if the measure of angle XYW equals 90 and the measure of angle ZYW equals 90, then the measure of angle XYW equals the measure of angle ZYW. Alright, see how that is my given, if, and my then is what I have right here in my current statement. Well, if you look, that's just going to be the transitive property of equality. And you know, we were used to seeing it saying, well, if A equals B and B equals C, then A equals C. Alright? Well, we're saying, well, if XYW equals 90, ZYW equals 90, then XYW equals ZYW. Okay? That's how that's working. Okay, for my next statement, like I said, your statements are going to be your challenging part. Hopefully your reasons and what you're going to call are going to be the easy step. Now this one says, because remember what we're trying to prove, that angle 1 is congruent to angle 4. Okay? So we're going to look at this and we're going to say, okay, well, I can look at this picture up here because this picture is what's helping me decide all this. All right? I can say, well, the measure of angle XYW equals the measure of angle 1 plus the measure of angle 2. Okay? Common sense stuff. And the measure of angle ZYW equals the measure of angle 3 and 4. Okay? That's pretty common sense too. So let's remember, my if is going to be the measure of angle XYW equals the measure of angle ZYW, and my then is going to be these two equations. Alright, so let's see that written out. It says, if the measure of angle XYW equals the measure of ZYW, then, and there's my two equations. Now if you look, that all we did was substitution. Now look here, we are substituting, or rather plugging in, okay, oh, well, the measure of XYW, and here's what we're substituting. That's how we get it, that the measure angle 1 plus the measure angle 2 is the XYW. And then the measure of angle 3 plus the measure angle 4, we're plugging in for the ZYW. Okay? Now look what they did here. They're trying to mess with you a little bit. Oh, look at that. I made some changes and didn't change it. I didn't like the substitution property, and that's why, because I changed it. Okay, I replaced it. Let's go over this part again. My if-then statement is still the same. I didn't change that the way I wrote it. But look here, it's actually the angle addition property. And we learned that. It's actually a postulate that is in, that was, I believe, in Unit 1, where we learned about the segment addition property and the angle addition property. And anyway, that is how we justify Part C. Sorry about that mistake. Alright, so now look what happens. It looks like they're saying the same exact thing, but look here. This ZYW is XYW now. Okay? And this 3 right here has become a 2. Alright? So you're thinking, whoa, this is going to be a big if-then statement. Remember, here's your if, here's your then. Okay. And don't let this, it's a whole lot of numbers and letters and everything to confuse you, but just stop for a moment and say, okay, I know that XYW is equal to ZYW. Okay? And I know that 2 is equal to 3. And so that's how all this is working. So let's look how the reason plays out. There's my substitution property of equality. See, I had just put it in the wrong place. Alright, here's my equations in my if statement. Okay? And then notice down here is my then statement with the equations that I find right here in Part D. Alright? Now then, this is where the substitution property of equality comes into play. Okay? Because I'm replacing ZYW with XYW. I'm replacing the measure of angle 3 with the measure of angle 2, because measure angle 3 and 2 are congruent. So I can do that. And then the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 4. And there again, write out your if-then statement. It's going to help you figure out what your property is. And I had to change it up so I'd have room to write everything. So here's my if. Here's my then. Hey, that's just the transitive property of equality. I guess I could say, hey, Jack, just like Cy. So if, let's see how this is working out as a transitive property. Remember, A equals B, B equals C, then A equals C. Alright, so that's how it's the transitive property. So now I can come down here and watch this. These measure of angle 2's in the middle here, they're going to disappear. Looky there. So now I've gone from the measure of angle, I've gone to the measure of angle 1 equals the measure of angle 4, which is what I'm supposed to prove. And remember my justification, this is going to be my if statement, this is going to be my then statement. And that, my friends, is the subtraction property of equality. Because what you're doing is it's just like a variable. You're subtracting the measure of angle 2 from both sides of the equal sign. And when you do that, they both become 0. So you're left with the measure of angle 1 equals the measure of angle 4. Alright, I know that this part right here is going to be your most challenging part. Okay, what am I going to do next? Let me tell you right now, what you do next isn't, it needs to be logical. Okay, there is no absolutely correct proof, but it has to be logical. And if it's not logical, then I'm going to tell you this isn't the logical next step. Alright, so don't be offended when I tell you it's wrong after I told you there's more than one way to do a proof. Okay, it has to be logical. Now then, if I was to just write this out without the if-then statements, this is the way it would look. And I just wanted you to see that. Real short and sweet. because we don't like all that writing in math. Okay, that's for English people. And so we like to write things out as brief as possible. But for us beginner proof writers, we need those if-then statements so we'll know what property or postulates to use. Let's do one more proof. I told you this video is going to be long. I hope you've taken a break. Alright, look at our given. Segment PT equals segment QT, segment TR equals segment TS. We've got to prove that PR equals QS. Well look, I've already taken this given information and I've marked up the picture. They told me PT is the same size as QT. They told me TR is the same size as TS. Okay? So always your first statement is the given. So you just write given. My second statement, look at this. If I know PT equals QT, right? PT equals QT. I also know that PT plus TR is going to equal QT plus TS. And you say, oh, how do you know that? Because see, these guys are congruent and these guys are congruent. That's how I know that. Alright? And remember, I want to get to my final destination of PR equals QS. And so this is my next logical step to get there. So my reason, if PT equals QT and TR equals TS, then PT plus TR equals QT plus TS. There you go. And that's going to be the addition property of equality. Okay? Addition, equal. Okay? So now I'm going to say, well, PT plus TR equals PR. Ooh, we're getting closer to that final proof. QT plus TS equals QS. Alright. So look, my if-then statement, if PT plus TR equals QT plus TS, then PT plus TR equals PR, and QT plus TS equals QS. So, if PT plus, oh, I'm not going to read all that again. Whew, that's a lot, too many T's, R's, Q's, and S's. This is going to be your segment addition postulate. You remember that one? That like the angle addition? Because here we said PT and TR equals PR. Right here, segment addition postulate. So my final statement is going to be PR equals QS. And remember my if-thens? If then, if then. And that's going to be my substitution property of equality. Okay, so that was our last example, I think. There we go. That's what it looks like without the if-then statements. Alright, but remember, I needed those if-then statements to figure out what my reasons were. And you have to give me reasons. Don't just give me if-then statements, okay? You have to give me reasons. The reasons is what I grade. Whew, a summary for this long video. A theorem is a mathematical statement that has been or is to be proven on the basis of established definitions and properties. A proof is a convincing argument that uses facts and logic to show that a conjecture is true. Two-column and paragraph form are two equally valid ways to write a proof. In a direct proof, you begin with the first statement, then draw a conclusion from that, then draw another conclusion based on one or both of those statements, and so on until you reach the conclusion that you want to prove. A paragraph proof is written in sentences, and there's more about this in the LMS. And in a two-column proof, the justification for each statement is written next to the statement. So believe me, I don't think your work here is going to be as long as this video was. You need to read the LMS, check out the reference guide, page 51 through 54, This 29 through 37 odd, those are actual proofs, but you don't have to do the whole thing like we did today. It's pretty much fill in the blank. All right? And please make note of any general questions you may have when you attend CC on Thursday. And I sure appreciate you guys listening for so long, and good luck on writing proofs.